So today is very similar to what we did the other day, where we're going to be given a description of some sort of parabola, and then you have to be able to write the equation of the parabola. I just made that up. But first and foremost, here are some answers to your Part 1 practice, so you can kind of take a look and see how you did. I'll take a million questions over these guys tomorrow. But I want to get into. We only have 2 examples today, so hopefully notes won't take 10 minutes like last time. So the problems are going to look like this. It says find a quadratic function for each parabola described, and it's going to tell you a couple pieces of information. First, it's going to tell you that the minimum value is -1. And then it's also going to tell you that the x-intercepts are 1 and 3. So I've thrown this graph over here just so we can kind of get a visual, so you kind of understand how this works, and then I'm going to talk you through how to solve it, because you won't have to graph it every time. So I want us to think the x-intercepts are 1 and 3. So my x-intercepts, I'll get it as close as I can, are 1 and 3. Okay? What happens is the x-intercepts kind of split your parabola. Remember, your parabola is the same on both sides. And so what that means is right in between my x-intercepts is actually my vertex somewhere. This is my axis of symmetry. So we know the axis of symmetry is 2. We just need to know, well, where is my vertex? Is my vertex way up here? Is my vertex way down here? We don't know. That's what this guy tells you. The minimum value is -1. That means the lowest my parabola is going to go is -1. So actually, your vertex is right here. Your parabola, if you were to sketch it, it's going to look something like this. Okay? So remember, the x-intercepts help you figure out where that axis of symmetry is. Your axis of symmetry is always going to fall right in between your x-intercepts somewhere. And then the minimum value, so timeout. So this is going to help you figure out your vertex. And so the number that falls right in between your x-intercepts is the x of your vertex, because it's your axis of symmetry. And then your minimum value, or sometimes it'll be a maximum value if your parabola is flipped upside down, is always going to tell you the y of your vertex. So that's going to help you figure out one part of the parabola. Okay? The next thing you're going to do is what we did yesterday, which is to use the roots to come up with the equation. So we had that formula we used yesterday. I'm going to use y today instead of 0 or f of x, and you'll see why in a second. But remember, it's x squared minus, you add the roots together. So 1 plus 3 is 4, and that's your x. And then you multiply your roots together. 1 times 3 is 3. So we have y is equal to x squared. I'm going to leave a little bit of space for a second. Plus 3. Okay? So the thing that this doesn't tell us is if there's an a value, is if my parabola is vertically shrunk or is vertically stretched. And so we have to figure out, is there an a value? And we do that by using this vertex right here. Instead of y, I'm going to plug in the number -1. We're trying to figure out if there's an a value. Are we vertically shrunk or are we vertically stretched? And then instead of x, you're going to plug in 2. So instead of x squared, it's 2 squared, which is 4, minus 4 times x, so it's 4 times 2, which is 8, and then plus 3. So we have -1 is equal to, I'm trying to figure out if there's an a, and then 4 minus 8 plus 3 is -1. So then I'm going to go ahead and divide both sides by -1. And so this tells me and further proves that, this tells me that -1 divided by 1 is just 1. So a is just 1. So there's no secret a here that's going to vertically stretch or vertically shrink our parabola. So your actual function for the quadratic that was described is f of x is equal to exactly what we found, x squared minus 4x plus 3. And that would be the answer to this problem. I have one more example for you. Again, I'm just going to graph it to kind of give you a visual of what's happening. But if you just kind of memorize, it should all work out. So this says we have a maximum value that's at 8 instead of a minimum value. So that means our parabola is flipped upside down if this is a maximum value. It means our vertex is at the top of our parabola. And the zeros are 3 and 7. That's just a different way of saying your x-intercept. So I'm going to go ahead and mark my x-intercepts at 3 and then at 7. And remember, your axis of symmetry is always going to fall right in between. Oh, there we go. And so you know directly between 3 and 7 is the number 5. So my vertex is 5, comma, and then, well, because this is x is equal to 5, and then my maximum value is 8, which means there is my vertex. And so if you were to graph it, it would look something like this, but that tells you that your vertex is 5, 8. Remember, that guy comes from here. So again, we're going to use that formula that we used the other day. Y is equal to x squared minus these two guys added together, which is 10x, and then plus them multiplied together, which is 21. And I want to figure out, is there an a value? Well, and we know that there is because our parabola is upside down. We know a is going to be negative for sure. But then we need to know, is there some number that made it vertically stretch or vertically shrink? And that's what we use our vertex for. So instead of y, we're plugging in 8. We want to know, is there an a? And we know it's negative. We just need to know if there's a number that goes with it. Instead of x squared, it's 5 squared, which is 25. And then it's minus 10 times x, which is 10 times 5, 50. And then plus 21. So we have 8, which is equal to a. And then when you add all of these things together, we get negative 4. And so then when you divide both sides by negative 4, we get that a is negative 2, which makes sense. We knew it was going to be negative because our parabola is flipped upside down, but we needed to know if it was vertically stretched or vertically shrunk, and it's been vertically stretched by 2. So to start writing your equation, we have f of x is equal to negative 2, and then in parentheses our original equation that we found using our zeros, or our x-intercepts, or our roots, all synonyms. This is a fine answer, but if you want to go ahead and distribute the negative 2 to all 3 of those pieces, your answer will be just that much better. So it would actually be negative 2x squared plus 20x minus 42. And this would be the equation for the parabola that we sketched right there. That's all we're doing tomorrow in class. I'll see you then.